Now, I want to talk about the heat equation today, but before we do that, we still have to talk about what heat actually means. And then also, I want to talk about a new variable that you probably haven't heard of before. So, we need to talk about what that is before we talk about the actual equation. So, first and foremost, let's talk about how temperature and heat are different. Now, a lot of people use these two terms interchangeably, and they are very similar, but they're not the same thing. So, temperature is a measure of kinetic energy in chemistry, and we've talked about this before. We measure temperature in degrees Celsius, degrees Fahrenheit, or in Kelvin. Heat, on the other hand, is the transfer of energy due to a temperature difference. So, in this picture right here, you can see that the heat is being transferred from the high temperature to the low temperature object. And you guys have probably seen this before. If you sit in front of the fire and warm your hands on the fire, that fire it has a higher temperature than you do. So that heat is being transferred from the fire and into your hands, the lower temperature object. So it's a measure of energy that's being transferred. That's what heat is. We measure heat in joules or calories. There is a reason also that joules has a capital J and calories has a little c. Now, you've probably heard this word calorie before for, the calories in the food that you eat. Now, those calories are very similar because it is, again, a measure of energy. But those calories, that c is capitalized because it's actually a kilocalorie of this calorie. So, meaning a calorie in your food is 1,000 little calories, which is the unit that we're talking about here. So you'll see that as kc as well, like kilocalorie. But just remember, 1,000 of these is 1 calorie in your food, and that's a measure of energy. Now, 1 calorie is also equal to 4.184 joules. It's just like a conversion when we convert miles to meters or something like that. It's another way to measure energy. Now, this is the variable that I was talking about that's probably new. It's specific heat or specific heat capacity, and it's going to be different for every single substance that we talk about. Okay, so specific heat capacity is the energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Now, that's a really big mouthful. What this really means is that when we have things with low specific heat capacities, they require less energy, less heat to raise their temperatures. So it's easier to raise their temperature. Think about this again, right? Looking at that really technical definition at the beginning of the slide. Something with a low specific heat needs lower energy to raise the temperature of 1 gram of the substance by 1 degree Celsius. So it's easier to raise that temperature of that substance. Things with a higher specific heat require more energy or more heat to raise their temperatures. So it's harder to raise the temperature. It's going to take longer to raise the temperature because it needs more heat in order to do that. Another way to think about this is just an object's willingness to change the temperature. So if something has a high specific heat, it actually is less willing to change the temperature because it needs more heat in order to change that temperature. Now, the equation for our heat calculations is going to be Q is equal to mc delta T, where Q is going to be the heat that is added or removed in order to change the temperature. We measure this again in calories or joules, and then a positive heat means we're adding heat into the system to raise the temperature. A negative heat means we're taking away heat from the system in order to lower the temperature. All right, so that's the different signs of heat. That's what they mean. M is the mass in grams of the substance. C is the specific heat capacity. Now notice how I have mentioned the units for heat and mass, and I will mention the units for temperature as well, but I don't mention the units for specific heat capacity. This isn't because it doesn't have units, because it does. But one thing that I want you to keep in mind and be really careful of is that sometimes you have to really look at what units they give you for specific heat capacity to make sure that your other things are in the same unit. So you'll see specific heat capacities like in calories per gram degree Celsius. You'll see it in joules per gram degree Celsius. You'll see it in calories per gram Kelvin, and joules per gram Kelvin. So there's all different types of specific heat capacity units, and they have to do with just what the heat unit is in and also what the temperature unit is in. And when I do some examples, I'll explain that again. And then delta T, of course, is our change in temperature. And I did put that it's in degrees Celsius, but sometimes it is in Kelvin as well. You just have to, again, look at what the specific heat capacity unit is. So remember that delta means change. That's the final temperature minus the initial temperature.